find dy dx given that y cubed equals 4x and y equals cos x squared minus 1. So we'll start with the first one here. So usually with differentiation, all right, with normal differentiation, y always is to the power 1. So if you see y is to a different power apart from 1, then you need to do what is called implicit differentiation. Okay, colleagues, implicit differentiation. If you see the y is the power for y is greater than 1, then you know you need to do implicit differentiation. So I'm going to illustrate this implicit differentiation. So what's going to happen is we're going to derive this y cubed and we're going to derive this 4x. Okay, so I'm going to say here y cubed equals 4x. So we're going to derive. So remember, with deriving, you multiply the exponent with the coefficient. Coefficient is just a number in front of the letter. So the number in front of this y is 1. Okay, 3 times 1, that is 3. Okay, then you subtract a 1 from the exponent. 3 minus 1, that is 2. Okay, so we get 3y squared. Now, when you derive y with implicit differentiation, okay, you need to add a dy dx. After you derive the y variable, you put in dy dx. Okay, equals. So the reason why we've put a dy dx, because with differentiation, you're always deriving y with respect to x. So x is the main variable that you're deriving. Any letter apart from x, you need to attach a dy dx. So that's why we put the dy dx with this y. Then this 4x to the power 1, again deriving, multiply the exponent with the coefficient. 1 times 4, that is 4. You subtract a 1 from the exponent. That is 0. So you have 4x to the power 0. Now remember, anything to the power 0 is 1. Okay, so you don't need to show 4x to the power 0. You just leave it like this. Okay, you just leave it as 4. Okay, then the next thing you do, you need to make this dy dx the subject of the formula. So to make it the subject of the formula, you divide both sides by 3y squared. Therefore, you're going to say dy dx equals 4 over 3y squared.